Welcome to another deep dive. Today we're going deep on satellite internet tech.
Sounds exciting.
Yeah, it is. We're looking at a research paper.
Oh, cool.
It's called Satellite Network Slice Planning with Handover Trigger and DRL-Based Virtual Network Embedding.
Catchy.
But don't worry, the ideas are really cool. Basically, this paper is about how AI could be used to make global internet access seamless. Imagine being able to get super fast internet from like a cruise ship or even Mount Everest.
That would be amazing, especially as companies like Starlink are putting thousands of satellites into orbit.
Exactly. And this research, by the way, it comes from a team in South Korea. They're tackling a really tough problem. How do you manage a network when all the towers are constantly moving around in space?
Yeah, that's a good question. It's very different from how things work down here on Earth.
Right. And that's where this idea of a deep queue network comes in. It's a type of AI that can learn how to manage all these connections as the satellites zoom around.
So it's not just about expanding internet access. It's about making it as reliable and fast as what we're used to here on the ground.
You got it. Think about it. You're on a cruise ship in the middle of the ocean, and you're streaming a live concert with no lag whatsoever.
Now, that's what I call progress. But how does this deep queue network actually work? It sounds like magic.
It is pretty magical. It all comes down to something called reinforcement learning. Have you ever heard of that?
I think so. Refresh my memory.
Okay, so think of it like teaching a dog a trick.
Oh, okay. I'm following.
You give them treats when they do it right. You reward good behavior.
Yeah.
Well, it's kind of like that with the AI. It gets rewarded when it finds ways to route data efficiently. It minimizes handovers between satellites and reduces that annoying delay we all hate, latency.
So basically, the AI is learning and getting better over time. Like through trial and error, it figures out the most efficient way to move data around the network.
Exactly. And the researchers found that it actually works incredibly well, much better than traditional methods.
That's impressive. How much better are we talking about?
Well, they introduced something called a handover trigger.
Handover trigger. What's that?
It's basically like having a sixth sense for when the connection needs to switch to a new satellite.
So it's predicting when the signal is going to get weak and switching before that happens.
Yeah, like changing lanes on a highway before you hit traffic.
Smart. That makes a lot of sense.
And this clever trick helps create a much smoother and more stable connection.
Ew. So how did it perform? Did they achieve their goal of reducing latency and handovers?
So they did. And the results are pretty remarkable. Get this, the AI system reduced average latency by a whopping 36% compared to the old way of doing things.
36%. That's huge. I mean, that's a game changer. It's not just about making satellite internet accessible. It's about making it truly competitive with terrestrial networks.
You nailed it. And it means we could be doing things like streaming and video calls seamlessly from anywhere in the world, regardless of location.
It's really exciting to think about the possibilities. This could be a real turning point for how we connect to the internet.
Absolutely. This research is a glimpse into a future where location is no longer a barrier to high-speed internet access. It's just the beginning, though.
Can't wait to hear more.
We'll dive even deeper after a quick message. Stay with us. Welcome back to the Deep Dive. Before just a moment ago, we were talking about all the cool things we could do with super fast, low latency satellite internet, like, streaming those concerts from cruise ships.
Yeah, it's pretty wild when you think about it. I mean, 36% lower latency, that's not just a small improvement, it's a whole new ball game. We're talking about real-time collaboration from anywhere in the world, remote surgery even, who knows?
It really does make you wonder, what's next? I mean, this research is amazing, but they only focused on part of the problem, right? They figured out how to get the signal to us on the ground. But what about all the communication happening between the satellites themselves?
That's right. And to be honest, that's where it gets even more complicated. Think about it. Managing the connections between thousands of satellites, all constantly moving. It's like, have you ever seen those videos of those huge flocks of birds, how they move together?
Yeah, like a murmuration, right?
Yeah, exactly. Like a murmuration, but in space. And each bird is a tiny computer zipping around the Earth at thousands of miles per hour.
Okay, yeah, that's a pretty crazy picture. So how do you even begin to manage something like that?
Well, traditional methods just won't cut it. We need AI, but not just any AI. It has to be able to handle massive amounts of data, make decisions in real time, and constantly adapt to a changing environment.
It's like we need to give the whole network a brain, right?
Yeah.
Something that can think ahead, predict problems, and reroute traffic before things get clogged up.
Precisely. And that's what researchers are working on right now. It's called distributed AI. Imagine each satellite having its own little brain, making local decisions, but also working together with all the other satellites to keep the whole network running smoothly.
So it's not one big brain controlling everything. It's more like a network of brains, all communicating and cooperating.
Exactly. And that kind of distributed intelligence could be the key to unlocking the full potential of satellite internet. It's still early days, but the possibilities are incredible. Imagine a network that's not only fast and efficient, but also incredibly resilient. No matter what happens, whether it's a solar flare or a technical glitch, the network can reroute traffic, adapt, and keep things running.
It's almost like giving the network a kind of survival instinct.
Yeah, exactly. And that's what's so exciting about this research. We're not just building a bigger, faster internet, we're creating a whole new kind of intelligent infrastructure that could change the world.
Okay, so let's talk about those changes. What does all this mean for us down here on Earth? How could AI-powered satellite networks actually impact our lives?
Well, for one thing, it could mean closing the digital divide. Imagine bringing high-speed internet to remote communities, places that have never had access before.
Yeah, that would be huge. It could revolutionize education, healthcare, economic opportunities, all sorts of things.
Exactly. And it's not just about developing countries. Even in developed countries, there are still plenty of rural areas that lack reliable internet access. Satellite internet could change all that.
And then there's the whole issue of disaster relief. Imagine being able to quickly deploy a network of satellites to provide communication in the aftermath of a natural disaster.
Right. And beyond that, think about scientific research. We could collect data from remote sensors, monitor environmental changes, explore the far reaches of space, all thanks to a robust and intelligent satellite network.
So we're talking about a technology that could potentially solve some of the biggest challenges facing humanity.
Exactly. And it all comes down to harnessing the power of AI. But of course, like any powerful technology, there are also potential risks. We need to be mindful of things like data privacy, security, and the potential for misuse.
That's a good point. It's not just about building cool technology. It's about making sure the technology is used responsibly and ethically.
Absolutely. But overall, I'm incredibly optimistic about the future of AI-powered satellite networks. I think they have the potential to make the world a better place.
I agree. But you know what? We haven't even touched on the most mind-blowing part of this research.
Oh, there's more.
Oh yeah, there's a twist. And it has to do with the way this AI actually learns and makes decisions. It's pretty wild. But we're going to have to save that for after the break. Don't go away. Welcome back to the Deep Dive. Now, before we got sidetracked there, I was teasing a pretty wild discovery in this research. Something about the way this AI learns.
Oh, right. Yeah, I'm curious. What's so special about it? It learns, so what?
Well, it's not just that it learns. It's how it learns and the decisions it starts to make. Remember we talked about the whole reward system, how the AI gets like virtual pats on the head for finding efficient ways to route data?
Right, like a dog learning a trick. The more efficient the route, the bigger the reward.
Exactly. But here's the thing. The researchers noticed the AI started doing some weird stuff. Sometimes it would choose a path that wasn't the fastest or the most direct.
Really? That doesn't seem very smart. What was going on? Glitch in the system.
That's what they thought at first. But then they started looking closer, analyzing the data, and they realized the AI was actually considering things they hadn't even programmed it to think about.
Okay, I'm intrigued. What kind of things?
Things like the overall health of the network. Like, let's say there's a particular satellite that's getting overloaded with traffic. The AI might choose to route data around that satellite, even if it means a slightly longer delay for that one piece of data.
So it's thinking about the big picture, not just the immediate task at hand.
Yeah, exactly. It's almost like it's developing an intuition about the network, a kind of sixth sense for what's going to keep things running smoothly in the long term.
Wow. So it's not just optimizing for speed, it's optimizing for resilience.
Exactly. And that's what's so mind-blowing about this research. It's like the AI is starting to understand the network on a deeper level than even the engineers who designed it. It's making decisions that might seem counterintuitive to us, but that ultimately lead to better outcomes.
It's kind of like, imagine you're driving to a destination. You could take the fastest route, but what if that route is known for traffic jams? A human might choose a slightly longer route that's more reliable, and it seems this AI is doing the same thing, but with data.
Yeah, that's a great analogy. It's like the AI is learning from experience, just like we do. But it's doing it at a scale and speed that we can only dream of.
It's both exciting and a little bit unnerving, isn't it? Like, what happens when AI starts making decisions that we don't fully understand, but that turn out to be better than anything we could have come up with?
Yeah. I think that's a question we're going to be grappling with more and more as AI becomes more sophisticated. But it's also what makes this field so fascinating. We're not just building tools, we're creating partners, collaborators.
Partners who might just teach us a thing or two about how to build a better future.
Well said. I think that's a perfect note to end on. A future where AI helps us connect the world, solve complex problems, and maybe even learn a little bit about ourselves along the way.
I like the sound of that future.
Me too. And to our listeners, thank you for joining us on this deep dive. We hope you learned something new and maybe even had your mind blown a little bit.
And remember, stay curious, keep exploring, and who knows, maybe you'll be the one to make the next big breakthrough.
Until next time, keep on learning.